Welcome again. So today we're going to talk about the percentage of something. And we're actually going to talk about something called mass percent. Now, we do this often, so let's not make this something tricky. So if you were to score something on a test, let's say you scored 70 out of 90, and you're like, how do I figure out?
78 out of 90. I would take 78 and divide by 90. And that would give me my percent, times 100.
Times 100. So we do percentages all the time.
Yeah,
so
yeah.
right now you just figured out the percent right that you got compared to the overall number. We're going to do the same thing right now. We're going to do it with atoms in a compound.
So it's like the mass percent of an atom. So let's take, well, what is mass percent? Should we write an equation on the board?
Sure. Why don't you?
So I would say that the mass percent is the mass of one divided by the total mass.
And when we say one, we're talking about individual atom in a compound.
And of course, you times it by 100, that's how percentages work. I mean, you guys understand percentages. So let's do that for a particular compound. I'd say calcium carbonate. So how would you do that?
So we're going to have CaCO3, right? And
Plus 2, minus 2, we played this game, so it's CaCO3. And I want to find the weight of the whole ballgame. So calcium weighs, let's simplify this right now. In class, I think you guys know that you'll have to use more specific numbers. But to make the video easier, calcium just weighs 40. How about we just
and we say weigh, we're talking about the molar mass.
Molar mass,
We're
yeah.
getting it from the periodic table.
Right here.
So we're assuming that
guy.
that's the, it's like, as if we, how terrible would that be? If we had a sign with our mass on it at all times, and mine would say 315 pounds, and you would say,
100.
Yeah, that's so depressing. But that's essentially what we have in the periodic
So
table.
let's just say it weighs 40, right? And then carbon weighs 12. And then oxygen weighs 16. Now, well, I know we're rounding, and usually you want to not round, but we're just going to make it simple on this because you get the idea.
Now, here's the thing. We have to be aware of the fact that we have...
Have you?
Oh, let's block it out of the way.
Come on, let me get back here.
So I want to start with the very beginning with the calcium carbonate?
No, we're good. We can see it.
Okay.
So let's just add them up, right? So you got 40 plus 12 plus 3 times 16. Actually, I know that in my head, folks. That's 100. It adds up to 100. So this is like a super easy one. Yeah.
Did you pick that up specifically because of that?
Yeah. So this is a super easy one. So the total weight of calcium carbonate is 100, right?
So we say this is a mass of 100.
It's 100 grams per mole.
Grams per mole.
So this is like a crazy easy one. So what's the mass percent of calcium in this?
So since calcium is 40,
It's 40 over 100 divided by 100. I don't need a calculator.
So that'd be 40%.
And carbon would be at 12%. And then this would be 48% because it's the 3 times 16, not just the 16. Watch that, by the way.
Now, lest you think that whatever the grams are here is the actual grams for the percentage. That works rarely. Congratulations on picking the perfect problem.
Now, let's do one a little bit more tricky.
That's the one that does not work quite. That doesn't get a race that actually works.
So I've got another example. Why don't we do gold 1 oxide?
Gold 1 oxide.
Yeah.
Well, that means we're going to have AU.
And O, right? But the charge of a gold 1 is plus 1. Oxygen is 2 negative. And so you need 2 golds, AU2O.
So this is going to be our formula.
All right. So we got to add up from periodic table guy the molar mass of gold 2 oxide. So there's 2 golds, and gold, if I recall, is like 197. Hold on, 197.0. And oxygen we know to be, let's round that to 16. So Mr. Dimitrievich, we have to find out the total mass of those together. So I've got the calculator, so that's 197 times 2 plus 16, right?
Yes, sir.
That comes to 410. So this is an add up to like pretty 100. So now we have to figure out what is the percent of silver, or gold, pardon me, and what's the percent of oxygen. So the gold is 197 times 2.
There's also a neat trick that you can do here, and I'm going to share with you real fast. So this is our overall molar mass, 410, right? Isn't this the molar mass of oxygen?
Yep.
So if we figure out the percentage of oxygen, we can subtract from 100, and then the remaining is going to be golds. You can do it both ways. You can multiply this by 2, but couldn't we just go 16 divided by 410 times 100 to get our mass percent?
And I get 3.9%.
3.9% is the percentage of oxygen.
That makes sense because it's 16 out of 400. So
Yeah.
it's a small percentage, so the rest is gold. So I'm just going to subtract this number from 100. on my calculator, and I get 96.1%, which you probably could do in your head. But yeah, that's it. Sometimes you can't do that cool trick if you've got 3 elements. If you've got 3 elements, well, you could get the first 2 and then subtract from 100 to get the third.
Yeah, as long as you have only one of the elements left
Left.
over, you can figure out the percentage. But it literally is just a matter of figuring out your over. And we use the term mass percent, but in reality, we're using the molar mass because we're assuming that we're dealing with 1 mole of all of these things whenever.
So, Mr. Dimitrievich, let's do one more example.
Yeah, let's try one that's kind of crazy or hard, right? So we're going to make believe elements here so you don't have to worry about looking up on the periodic table. So we're going to go given 5.98 grams of imaginary element X, and we're going to go 47.9 grams of imaginary element A, and then we're going to give a real element and 3.67 times 10 to the 24th atoms
Atoms. Oh, wow.
of, let's go with O.
All right.
So here's
So
the
oxygen.
Yeah, so if we had grams, grams, and grams, we could add up all 3 of these grams and then figure out the percent by mass by taking each of them and dividing by the total.
But we have 1, 'cause it's a mass percent. So before we were just using the formula to define the mass, but now we actually know the mass of A and B, or X and A. And now what we need to do is need to get the grams of our oxygen, the O, right? So I think we have to just do, remember this is a molecules to moles to grams problem. So it's 3.67 times 10 to the 24th atoms of O. Now we look at the mole things, the conversions. This is going to be 6.02 times 10 to the 23rd over 1 mole. Flip it or leave it. You're going to flip it because atoms needs to go in the bottom, the 6.022 number. Yeah, and then 1 mole. I think you'll need to go on the next line for this because you need to make a line.
We do. So we're going to pick a line here, and this we're just going to pick it up right below here. But
Below.
remember, we did that so that atoms can cancel.
Right. And
We're
then-
at moles of O.
And then we get out our periodic table, right? This guy right here. And of course it's 15.99. And I think you've got that backwards, Mr. Dimitrievich.
I sure did.
So you're going to say moles has to go on the bottom of the next fraction, 1 mole, and then 15.999. And so Mr. Bergman's going to get the trusty dusty calculator out, and I'm going to take 3.67 double E 24 divided by 6.022 double E 23 times 15.999. I get 97.51.
This is all we really care about here, right? So we know that this is the number of grams we have of O, which is the only one that we
Yeah.
really know. We have 47.9 grams of A, and we have 55.98 grams of X. If we add them all together, we're going to end up with our total.
And I have the total, Mr. Dimitrievich.
So let's write our total.
I have our total to be 151.4.
This is
That's
our
the
total.
sum of these 3 numbers.
These 3 together make this. So couldn't we figure out the percentage of any of them simply by dividing that by the total
So
number?
we'll take X, which is 5.98, divided by 151.4, and sum total is 3 times 100, 3.9%. I'll just give it 2 digits.
Okay, and then let's do it for A.
A is 47.9 divided by 97.51.
151.4.
So I'm going to take 47.9 divided by the same number, 151.4, and here we get 31.6%.
By the way,
Now we can do the shortcut you talked about before, that subtract from 100, because this plus our oxygen is going to add up to 100. So I'm going to just take 100
subtract
minus 3.9 minus, what was it again?
31.6.
31.6. Survey says 64.5. So 64.5 is our oxygen. So that's how you do percent compositions, guys. It's crazy, not that hard. It's grams.
By the way, if you're like, I don't want to do it that way, you're not my real dad, right? If this is you, you could just take 97.51 and divide it by the 151.4. You're going to get the exact same number right here.
Yep.
That's all we're really doing here, right?
Percent composition.
All right, see you next time.
Bye.